Hi, my name is Billy Jackson, and I teach mathematics at North Shore Community College. This lesson is going to be on adding and subtracting mixed numbers. When adding mixed numbers, you can add the fraction parts together first, and then add the whole numbers together separately. And that's the best way to go about attacking a problem like this. So for example, add 7 1/6 plus 1 2/3. First, I like to rearrange it and write the problem vertically instead of horizontally. Oops, plus. Okay? So we can add the fraction parts together first and then the whole numbers together. So in order to add the fraction parts together, we need a common denominator. So I'm going to rewrite these whole numbers here. I can copy the whole number part. And I'm going to rewrite my fractions with the common denominator, which in this example, the common denominator would be 6. Okay? So I'm going to do a little scratch work over here on the side. I need to build up my fractions. My original first fraction was 1/6. And to rewrite that with a denominator of 6, well, the numerator just stays the same. And for my next fraction, 2/3, I need to write this with a denominator of 6. So to get from 3 to 6, you get there by multiplying by 2. So I'm going to do the same on the top. And my new numerator over here is 4. Okay, so just like I said, we can now add the fraction parts together first. 1/6 plus 4/6 is 5/6, and 7 plus 1 is 8. And that's your final answer. If my fraction could be reduced, I'd want to do that, of course, but 5/6 can't be reduced, so the final answer is 8 5/6. Now let's take a look at an example of subtracting mixed numbers. We're going to attack this the same exact way. First, I always like to write these vertically instead of horizontally. I find that's easier for me. Okay? And we're going to, again, subtract the fraction parts together separately from the whole number parts. So in order to subtract our fractions 2/3 and 3/8, we first need a common denominator. So I'll rewrite these fractions. The whole number part is going to stay the same. And I need a new denominator. The common denominator for 3 and 8 is going to be 24. Okay, so let's do some scratch work over here. My original fraction of 2/3, if I want to rewrite that with a denominator of 24, how do I get from 3 to 24? I multiply by 8. So I have to do the same thing to the numerator. And now my new numerator is going to be 16. All right, so I'll do that for the bottom also. My fraction part here is 3/8. And I need a new denominator of 24. I get from 8 to 24 by timesing by 3. So I have to do the same thing on the top. 3 times 3 is 9. So that is going to be my new numerator, 9. All right, and now I'm all set to subtract. Just like we said, we're going to subtract the fraction parts together first. So 16 over 24 minus 9 over 24 is 7 over 24. And then the whole number parts separately. 9 minus 5 is 4. Great, and that's the final answer. I'd reduce it if possible, but 7 over 24 can't be reduced. Okay? This method of doing the whole number parts and the fraction parts separately only works with adding and subtracting mixed numbers, not multiplying and dividing mixed numbers, which you'll see in the other video. All right, this example is similar, but you're going to see something a little bit different happens. So let's attack this just like we did the last one. Start by setting it up vertically. Okay? And if we want to add the fraction parts, 5/6 and 2/3, we need to first rewrite them with common denominators. So the whole number parts aren't going to change. My common denominator for 6 and 3 is going to be 6. So again, I'll do some scratch work over here. 5/6 with a denominator of 6, well, that's not going to change. They'll stay as 5. And 2/3 with a denominator of 6, that new denominator is going to be 4. So I'll put 4 in here. And let's add. So I'll do my fraction parts together first. 5/6 plus 4/6 is 9/6. And 8 plus 4 is 12. All right. So that looks like we're finished, but there's a little bit of a problem here. We have an improper fraction inside of a mixed number, which we definitely don't want here. I was actually just explaining this dilemma to a student earlier, and this is the example I gave that student. I said, what if I told you that I am 5 feet 14 inches tall? Does that sound a little funny to you? And my student said, yeah. And I said, well, how would you correct me? And she said, well, you're not 5'2". You're not 5'14". I would say you're 6 feet 2 inches tall. And I said, that's correct. Why did you change that? How can you change it like that? And she said, well, there are 12 inches in a foot. So I would take 12 inches out of the 14, which is 1 foot, which bumps that 5 up by 1 to a 6. And I said, right. What you don't realize when you talk about 5 feet 14 inches tall is that this 14 is actually part of a fraction. Every foot is 12 inches. So whenever you say something like 6 feet 2 inches, you're really saying 6 and 2 out of 12 feet tall. Okay? So we're going to take that same logic to attack our final answer we had over here. Okay? So what we have here is 12 and 9/6. Just like 14 inches over here was more than 1 foot, well, 9/6 is more than 1 whole. So we need to fix this. We can take 1 whole out of 9/6, and if we pull out 1 whole out of 9/6, we're left with 1 whole and 3/6 left over. So what we can do next is take that 1 whole, combine it with our original 12 wholes, and that gives us with a total of 13 wholes and 3/6, which we could then reduce that fraction and get a final answer of 13 and 1/2. Kind of small there, but that would be the final answer, 13 and 1/2. So that example was a bit of a unique case, and we're going to see another unique case here also with this subtraction problem. So I'm going to set this up just like the last one. I'm going to set it up vertically. I always find that's an easy way to organize these problems of subtracting and adding mixed numbers. Okay, so again, I'm going to subtract the fraction parts together first, but I need a common denominator before I can do that. Oops, I made a little mistake there. Oops. My problem wasn't 3/18, it was 5/18. Glad I caught that. So let me get back to writing this down. I copied down my whole numbers, and my fraction parts need a common denominator. So for 18 and 12, my common denominator will be 36. And let me do that scratch work real quick to find my new numerators. My new numerator for the first fraction will be 3. And for the second fraction, 5/18, with a new denominator of 36, my new numerator will be 10. All right, so now I can subtract. But there's a bit of a problem. 3/36 minus 10/36 won't give me an answer. I can't take 10 away from 3. So what I have to do is something called borrowing. Just like we borrowed with whole numbers, we're going to borrow here, except I guess it's a little bit different. So if I were to do 81 minus 15, what we would normally do is we can't do 1 minus 5, so we'd have to borrow 1 from the 7, and then we would add 10 onto the 1 and make it an 11. Right? And the reason why is because each of these 10s are worth 10 1s. Okay? But in our fraction over here, that's not exactly the case. 1 whole is not worth 10/36. 1 whole is worth 36/36. So what we're going to do is when we borrow 1 whole, we're going to add 36/36 to our fraction part. So we're going to add 36 onto this already 3 and now have 39/36. And then we can finally subtract. We can do 39/36 minus 10/36 is 29/36. That doesn't look like a 9. Let me fix that. 29/36. And then 6 minus 3 is 3. And that right there is going to be our final answer. All right, great. So now you try. Pause the video and try to solve this problem. When you press play again, I'll show you my solution to see if you got the correct answer. All right, let's see if you got the same answer as me. I'll start by setting it up vertically, just like I have been all video long. I'm going to rewrite my whole number parts, and I need a common denominator here for 3 and 4, which will turn out to be 12. Okay? And as I rewrite my fractions 1/3 and 1/12 with this new denominator of 12, I'm going to see my new numerators must be 4 and 3. All right. So now I can subtract. 4/12 minus 3/12 is 1/12. And then 6 minus 4 is 2. And there you have it. That's the final answer. I hope you got that same one as me. All right. So keep practicing, and we'll see you soon.